Hello everyone, and welcome to the demo of ZenFlow. ZenFlow is a platform that automatically converts one programming language into another. For example, transforming a legacy codebase into a modern system. It's simple. You upload your legacy code. ZenFlow's automation gets triggered, and once the process completes, your modern code is ready to use. In this video, we'll explore how ZenFlow works and the design principles that make it fast, reliable, and trustworthy. ZenFlow doesn't just rely on large language models, or LLMs, to translate code. It amplifies their power through a governed orchestration layer, a structured system that keeps every step in check. There are 4 key design principles that drive ZenFlow's architecture. Let's go through them one by one. First is modular orchestration. ZenFlow breaks the entire codebase into smaller chunks, each representing a specific operation or functionality. It also maps how these pieces interact across files. It's scalable. No matter how large the system is, ZenFlow processes it chunk by chunk with the same precision and speed. Now that the chunks are ready, ZenFlow sends them to the LLM to generate the modern equivalent. ZenFlow guides the LLM through a controlled workflow. It plans what needs to be built. It generates the modern code. Then it checks, is all business logic preserved? If something's missing, it fixes it. And finally, it ensures the code is fully executable. ZenFlow maintains complete transparency throughout the entire process. You can see exactly what changed, why it changed, and how it was fixed. This end-to-end visibility builds confidence and makes compliance and auditing effortless. Finally, ZenFlow is language agnostic and convert it into modern platforms. This flexibility makes ZenFlow a truly universal modernization platform, adaptable to any enterprise environment. Thank you for watching. Now, let's look at the actual working of ZenFlow. This is the landing page. Here, we can see that the only manual input required from the user is to upload the legacy code system. In this demo, we'll be uploading a COBOL code base. The user has the option to choose between an open source or a closed source LLM. ZenFlow also provides an option to upload coding guidelines. If such guidelines are uploaded, ZenFlow will use them. If not, it automatically applies the default coding policy. After the setup is complete, the user simply clicks Start Migration. That's it. These are the only manual steps required. From here, ZenFlow takes over automatically. The 4 key stages, extraction, generation, testing, and fixing, are triggered in sequence to generate the modernized code base. First is extraction phase. Here, ZenFlow begins by parsing the entire legacy code base line by line and collecting the information into an inventory of operations. And each extracted operation includes full details, such as the file name it belongs to, the exact line numbers, the source code, the purpose of the operation, its input and output values, and any conditions or logic associated with it. Next, we can see the call graph. This view shows how all the operations are interconnected across different files in the entire codebase. It maps the flow of calls between operations. Then comes the interface catalog. This page lists all the interfaces and shows how operations exchange data between them. It captures exactly how values are passed, how inputs and outputs flow through the system, and how each component interacts to execute a process. Finally, we have the glossary. This converts all that technical information into a human-readable format, listing the different operations, data structures, and system concepts in simple, understandable language. So, by the end of the extraction phase, ZenFlow has captured the complete operational and structural blueprint of the legacy system. Once extraction is completed, the generation step is triggered automatically, beginning with the planning agent. In the call graph, we can see all the operations that will be used to generate the modern Java codebase. For each operation, ZenFlow captures details such as which functionality it belongs to, which functions it is called by, and the corresponding execution steps, including file names and line numbers, showing exactly where those operations are executed. Next, we can see the architecture that the planning agent has designed to create the modern system. Here, the structure is organized into modules, operations, and the related DTOs, entities, and utilities. For every module, ZenFlow shows information like its complexity, its purpose, the list of operations it contains, and the DTOs related to it. We can also look at the operations view, which shows each operation's complexity, the module it belongs to, and the DTOs it uses. Then comes the coding standard section. Since the modern target system here is Java, ZenFlow analyzes and applies the corresponding Java standards, including which frameworks, components, and conventions to use, what the package structure should be, and what naming conventions to follow. It also lists the mapping between COBOL and Java code, so we can see exactly how legacy COBOL components are represented in the modern system. Once the planning step is complete, the generating agent is automatically triggered. On this screen, we can see how many operations, methods, dependencies, and tests were performed to generate the code. For every Java class that's created, ZenFlow shows its one-to-one mapping with the original COBOL, reference file, and line numbers. We can also see the methods that were mapped, their references in COBOL, and the test cases that were executed to produce the equivalent Java version. Once the code has been generated, the review and fix agent starts its process. The review agent verifies that all business logic from the legacy system has been properly migrated. If anything is missing, the fix agent fixes the modern system accordingly. This step also checks whether the generated Java code is in an executable state. If not, to make the code executable. This screen shows a summary of all those fixes, how many iterations it went through, how many files were fixed, how many stubs and stub classes were generated, and the detailed list of each one. Finally, the modern code reaches an executable state. This view shows what modules were executed and what configurations were used to successfully run the Java codebase. ZenFlow now enters testing. It auto-generates unit test cases for every operation, including positive, negative, and edge cases. For each test case, you can see the description, the input values, the expected outputs, and other details. These tests run on both the legacy COBOL system and the modern Java system. ZenFlow then produces a test report showing the operation name, its equivalent COBOL operation, the status, and, if it failed, the mismatch, the root cause, and the recommended solution for the LLM to fix. Under the summary page, it shows totals for the number of operations tested, the total test cases, tests passed, and tests failed. Failed test cases move to the fixing agent. Here, the agent identifies the original issue, documents the attempts made to fix it, and records what changed. The lines added, lines removed, methods added, methods modified, and other code changes. You'll also see the final fix details, the key improvements. The updated code then goes back to testing. Round 2 testing runs with the same structure. and the summary, with updated totals for operations, test cases, passed and failed. The fixing agent performs the second round of fixes. Again, it shows the original issue, the fix attempted, and the final fix details, including what changed in the code. The code returns to testing once more. Round 3 summary shows the end state. Here, we can see no further test failures. After all steps are completed, the reconciled modern codebase is ready to download, and the entire modernized executable codebase is ready to use. ZenFlow, making legacy modernization seamless, automated, and reliable.